Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of balancing redox reactions using the ion-electron method. So the ion-electron method, as I just said, is a process for balancing redox reactions by using half reactions balanced separately. That's the key to it. So we're going to look at a net ionic equation, and we're going to end up basically just taking the oxidation half reaction and the reduction half reaction, looking them individually, and end up balancing their charges. So the skeleton equation only shows the ions and sometimes molecules, because some things don't ionize in solution involved in the reaction. So when we're doing these, there's a series of steps: an acidic solution or basic solution. If it's in neither of these and they just want you to use an example that doesn't have any hydrogen or oxygen, and it's not an acidic or basic solution, then what you do is you break up into half reactions, and you remember the facts of oxidation is the process of losing electrons, and when you lose electrons, your oxidation number goes up, more positive. So as a result, I guess I could write this stuff down for you. So if you remember, basic example, doesn't matter what A and B are, the key is looking at their charges, their oxidation numbers. In this case, because they're ions, their charges and oxidation numbers are one and the same. So we only care about the cations in the skeleton equation, and in this case A went from +1 to a 0. The only way it did that was if it gained one electron. Gaining an electron is a process of reduction, and losing an electron, as B did, actually lost 2 electrons, is oxidation. So hopefully you're familiar enough with these two concepts to understand that even though this is a process of oxidation, this is the reducing agent right here that allows for reduction to take place. Why? Because it gave up 2 electrons. Without it, there'd be no reduction. And this would be the oxidizing agent. It's able to accept the electrons given off. Okay? So it's always the opposite for the agents. So now that you know that, what we have to do is balance the electrons. So hopefully you can see that this is a 2, this is a 1. If I multiply the top equation by a 2 here, and here, now the electrons will cancel, and then all you do is you add the 2 equations, and when you do that, you're going to get a 2a plus Now what you need to notice here is that the electrons are the same number on either side. Alright, so if they're not the same number, what you need to do is recheck your work. You probably did something incorrectly, and you can then literally cancel these electrons to get this net ionic equation here. And it's balanced. Okay? So I hope this has cleared up the basics of ion-electron method. Now there are 2 other scenarios. You will be looking at it. I'll do a separate video for each one, a concept video and example videos for each one. But we will have a scenario in which we're doing an acidic solution And there are steps for that. And then for a basic solution, you do all the steps for acidic and then just do a couple extra steps. And we'll go through this example as well. But then for basic, there's additional steps to do. And it's not that bad. It looks overwhelming and tedious at first, but if you go through these basic steps that are outlined here, you will not have any problem doing these. All right. So it's just a matter of, are you going to take the time to do these, go through the steps, kind of understand what's going on, and if you just follow these steps every time, it'll work every time. So check out the concept video for the acidic solutions. Odds are you're going to get one in acidic or basic or both. You might get a couple that are without, so I just wanted to make sure I touched on that. But make sure you understand how to do all three methods. I hope I've eliminated enough doubt for you to start the problems. Practice, practice, practice. Thank you and have a nice day.